I received a secret mission from PCBWay. What was it? It's to design a special badge celebrating PCBWay's 11th anniversary. And this is how it turned out. It might look simple, but getting here wasn't easy. Along the way, I faced some real struggles and I had to make a few tough decisions to keep the project on track. But in the end, the design was completed and now it's available in their store. And these badges will be making their debut in San Francisco. So what makes this badge special? What kind of struggles did I face? What difficult choices did I have to make? And how did I overcome them and bring this design into mass production? Well, in today's video, you will find out. This video is sponsored by PCBWay. The request? To take an existing badge design and turn it into a fully functional, working PCB. The graphic design was already completed, but the circuitry and firmware still had to be built from scratch. To make things even more challenging, they were hoping to have everything finished within just 1 month. Alright, let's get to work! The graphic design was already provided for this project, and this beautiful artwork was created by GJ. I hope I'm pronouncing that right. Just in case, I'll put the correct spelling up on the screen. Now, bringing a graphic design like this into a functional PCB layout was actually a first for me. To be honest, I'm not very experienced with that process yet, but I somehow figured it out and successfully imported the design by creating a special footprint for it. But for the sake of time, I'll skip over that part in this video. Today, we will be focusing on the circuit design, how I approached it, what decisions I had to make, and how it all came together. Okay, let's dive in. For this design, we need to drive 11 LEDs for obvious reasons. The LED were meant to blink in a specific pattern, and according to the original concept, the plan was to use an 80-tiny-85 to control the blinking. I wanted it to stay as faithful to the original concept as possible, so I decided to go with the 80-tiny-85. Looking back, I realized that for such a simple blinking pattern, we could have put it off without even using a microcontroller. I believe some of our friends have done exactly that. Using the 80-tiny-85 added not only extra component cost, but also more complexity to the circuit than necessary. Unfortunately, I only came to this realization about a week into the project, and by that time, the first version of the circuit design was already done. At that point, switching to a simpler solution would have caused even more delays. So after discussing it with the team at PCBWay, we decided to stick with the original plan and use 80-tiny-85 circuit. And that was my first real struggle in this project. To get started quickly, I didn't want to build everything from scratch, so I decided to base my design on an existing board, the DigiSpark 80-tiny-85. Luckily, I was able to find not just the board itself, but also its schematic online. Having a working reference circuit was definitely a lucky break, but it also introduced a new problem. That board was designed to run at 5 volts, either through a USB connection or an external 5-volt power source, which isn't a problem at all. Actually, it is a relatively ideal configuration for 80-tiny-85. For that purpose, it even included a regulator to step down the voltage if the input was higher than 5 volt. If you check the 80-tiny-85 datasheet, you'll see that it runs perfectly fine at anywhere between 2.7 volt and 5.5 volt. But since this was going to be a badge, I couldn't rely on having a USB cable or a 5-volt power supply connected all the time. And I didn't want to add extra circuit to boost from 3-volt to 5-volt either. That would complicate the design and increase power loss. Ideally, I wanted the badge to run on a coin cell battery. That meant I needed to adapt the original 5-volt circuit to work reliably at 3-volt instead. However, using 3-volt means you have to give up the bootloader. I will talk about more later. And that was my second struggle in this project. The next thing that kept me up at night was this. How am I going to program the chip? You might be thinking, wait, isn't that easy? Just plug it into a USB port and upload your code. Well, it doesn't work like that. If you are using something like DigiSport 801085, then yes, it already comes with a bootloader pre-installed. That means you can just install the driver on your PC, set up the board package in the Arduino IDE, and upload your code right away. Simple enough. But when you are building your own board, your 801085 doesn't come with a bootloader. It's completely blank. You have to flash the bootloader yourself before you can even start programming it via USB. And that became my third real struggle in this project. Thankfully, there were solutions. At 3.3 volt from the USB regulator, the 801085 operates well, making both the bootloader and the main program reliable. First, I modified the circuit so it could run on both USB power and a coin cell battery. When connected to USB, the board receives 5 volt, which is stepped down to 3.3 volt using an NCP 1117. The 801085 then runs on that regulated 3.3 volt. When running on a coin cell, however, the 801085 is powered directly by the 3 volt from the battery. Coin cell operation was a key requirement for this batch, so we needed to make sure it could run stably at 3 volts. However, when powered by a 3 volt coin cell battery, problems arise. The micronucleus bootloader relies on the 801085's internal 8 MHz RC oscillator to handle USB communication reliably. This means I cannot use a bootloader when powering the chip with a coin cell battery. Because of this, I decided to skip the bootloader entirely and flash the code directly using an Arduino as an ISP programmer, with ARVdude to handle the uploads. This method was fine for development and testing, but it's not reasonable to expect the recipient to handle it, especially if the badge is given as a gift or souvenir. Ideally, the badge should come pre-programmed and ready to run right out of the box. And that became my fourth and final struggle on this project. Luckily, there was a solution for this too. For this project, I didn't just use PCBWay for PCB manufacturing. I also took advantage of their PCB Assembly service. Unlike when I solder components by hand and have to supply my own 801085 chips, PCBWay sources all the components for you, including the microcontrollers. And here's the best part. Since they order the chips in bulk, they can request the supplier to pre-flash the firmware before shipping the parts to PCBWay for assembly. So by the time the 801085s are soldered onto the boards, they already contain the LED blinking program. All you have to do is insert the coin cell battery and it works right out of the box. I simply provided them with the pre-compiled binary and the correct fuse settings, and they took care of the rest. After overcoming all those struggles, seeing my PCB design finally go into mass production at this scale was both nerve-wracking and exciting. Big thanks to PCBWay for giving me this opportunity. It turned out to be an incredible, valuable experience. Alright, that's it for today's video. If you enjoyed it, please give it a thumbs up and subscribe for more. I've also prepared a write-up, and I'll include the link in the description below. Oh, and by the way, it can also be used as a dev board, with or without the bootloader. So if you've got one on hand, don't hesitate to give it a try. and feel free to experiment with your project ideas. Thanks for watching, and I'll see you in the next project.